So again, focusing on the time series patterns, we're looking for data over a period of time, and we're looking to see if some type of pattern or trend is going to develop. You'll notice trend is one of the time series patterns that we look at. So here are some of the ones that we'll talk about in this chapter. Horizontal, trend, seasonal, sometimes trend and seasonal takes place, and then cyclical. All right, so a horizontal pattern. Remember we said when we map the data out on a time series plot, the horizontal line is going to be our time, and then the vertical axis is going to be the actual data values. On a horizontal pattern, what you'll notice is that the data fluctuates around a consistent mean. So you're not going to see a whole lot of peaks and troughs or high points and low points. You'll notice that while it's not a straight line, there is a consistent mean or consistent average that takes place in your data. Sometimes changes in business conditions, though, will result in a shift in that horizontal pattern, maybe a higher or lower mean, but then over time you'll continue to see that it's still that mean or that kind of consistent mean that's taking place. A trend pattern is over a longer period of time. So when we were looking at, I'll come back up here, when we were looking at these, we may have been looking at days, weeks, months, quarters. We may have been looking at years, but when you look at a trend period or a trend pattern, you're definitely looking over a much longer period of time, typically a series of years that you're looking at. And some of the long-term factors that you might see change over this pattern would be population, demographics, technology, customer preferences. So all those things kind of follow a trend pattern. The trends have changed. Kind of, if you want to think back, maybe a recent trend that changed is when we went from four-door vehicles being the trend to mom vans, minivans, to now SUVs. That might be a trend in one of the business patterns that you would see. It could be linear or nonlinear. Doesn't necessarily have to be a linear trend. And definitely a multi-year movement is where you would see this type of data or this type of pattern. Seasonal. Now I'm actually going to jump to the very bottom bullet point first when we talk seasonal. When we talk seasonal, I don't want you to think spring, summer, fall, and winter. Seasonal can be any, it could be a week, month, day, quarter. It's just a pattern you see that wraps around what you're going to call your season. So let's say a seasonal pattern might be a Saturday, Sunday trend that could, or a pattern that you see compared to the rest of the week. You can consider that a seasonal pattern. It's a repeating pattern of highs and lows over a period of time within a year. In class, one of the examples that I gave is when I was in high school, I used to work at a snowball stand, and I always age myself saying, you know, back then snowball stands were just that. They were open in the summer months and they sold snowballs. One of the stands that I worked at, or the stand that I worked at, she was the first person to do a stuffed snowball, putting the ice cream in the snowball. Now when you think of snowball stands such as Brooks Snowballs or others in the area, what do you think of? Well, they're now year-round businesses, right? They also sell not only snowballs, but they may sell ice cream. They may sell nachos. Some of them sell Buddha and other fried foods. So they've tried to take the seasonality out of the business. I am sure you'll still see some type of seasonal trend because I'm sure, especially in the snowball sales, those are going to be higher in the warmer months compared to the lower months. Other seasonal trends that we talk about in class are lawn care services, pool services. And again, a better, stronger business structure is going to try and take the seasonality out of it. They'll try and add other services when their peak season is over that they can still consistently have an income, but you may still see the seasonal pattern taking place. Other seasonal examples would include if you're a Mardi Gras business, a Halloween business, or if these are side businesses that you open, those may have some seasonality that goes along with it. So a seasonal pattern, the seafood industry around here. Again, you may be a seafood business that's open all year long, but you'll have different seasons in that, the crawfish season, shrimp season, crab season, and so on. And you'll see sales and cost peak and trough accordingly. It says some time series actually turned out to be both a trend and a seasonal. And so you may have to use a different type of forecasting method when this happens. Find ways to maybe just look at one aspect of that or the other when you're doing the forecast. A cyclical pattern. A cyclical pattern is, it says alternating sequence of points above and below a trend line lasting more than a year. Think of a business cycle when you think of a cyclical pattern. One of the examples, or some of the examples I give in class, is let's start with the iPhone. What happens every time a new iPhone comes out? That's a cyclical pattern. So sales are going to do a certain thing, customers are going to do a certain thing, how we handle the older versions of those products and the sales for that, and so on. That would be a cyclical pattern. A lot of technology is definitely in cyclical patterns. So like the Microsoft products, every time a new version of Microsoft Office comes out, you may see some type of cyclical pattern in your business. And again, these aren't something that happens every week, every month, every year. When it has the major upgrades, the major renovations, that's something that happens over a multi-year period of time. Once you produce the product, it's multiple years down the road before you come up with the next version of the product. So cyclical is sometimes very difficult, not only to predict, but to forecast. Because sometimes that new product comes out and it just doesn't do what the past products have done, market-wise, sales-wise, and so on. So if it's a cyclical pattern, and those aren't anything we're going to try and forecast in this chapter, if it's a cyclical pattern, it is a little bit harder to forecast. So I talked about this in the first video, selecting a forecasting model and selecting one that works the best with your data, with your history of data. A lot of times you're not just going to pick a model, a forecasting model, and go with it. You're going to run your data through several models, and then you're going to look for, which is what we're about to talk about, the error in those models. How close are those models to the actual forecast, or what's actually happening in your business cycle, in your business pattern? And how close is that forecast to what's really going on in your business? So how we're going to look at that is we're going to look at what's called the forecasting accuracy. And in blue, there's your definition. Measures the forecast accuracy used to determine how well a particular forecasting model is able to reproduce the time series data that's already available. So how close is this forecast to replicating what's already happened in your past business data? We're going to look for the one, when we look at these multiple forecasts, one of the questions we're going to have to answer is, okay, well, out of these two or out of these three forecasts, which is the best? And what we're going to be looking for is the method, the forecast that has the most accuracy, the one that has the least amount of error. So when you think most accurate, you're thinking which one is the closest to what's currently happening in my business data and the trend or patterns of my business data, which one's the most accurate. And how we're going to forecast that, or how we're going to calculate that, is something called the forecasting error. We're going to look at the actual value that was sold, produced, bought, whatever that month, compare it to the forecast, and that's going to give us our FE, or our forecasting error. And then we're going to use that forecasting error in a few different ways to calculate accuracy and to help us determine what is the best way, or what is the best forecast for our particular business and business data. A positive forecast error, so if we have a positive number It indicates that the forecasting method underestimated the actual value. If we have a negative forecast or a negative FE, then the forecasting model overestimated the actual value. So those are also some things that you want to consider and look at. Once we have that forecasting error, we're going to look at a few different ways to analyze it or measure it. We could basically just look at that average error. The mean error is taking your FE, taking the average of it. This is probably the least useful of the approach because we just talked about some would be positive, some would be negative, and in the end, they basically end up offsetting each other a lot of times. So it makes it a little harder to understand or calculate that error. So what we do instead is we take the error and we take the absolute value of it. So we don't care if it's overestimated or underestimated, but what is the difference? Just how far is that difference? So this is called the MAE, the mean absolute error. And that's one of the ways that we're going to look at our mean absolute error. How far is our forecast from our actual values? And again, when we're comparing errors, we always want to look for the lowest of any of these accuracy measures that we're looking at. Mean square error. This is another way that we look at forecasting errors. This is probably one of the more common ways that you hear when you look at different forecasting methods. Again, it takes the positive and the negative out of it because it takes the forecast and squares it. And if you remember in some of our couple of past chapters, chapter 11, chapter 14, sum of square, and different things like that, squaring is a statistical way that we analyze our data. So the mean square error, again, take your FE, take your forecasting error, square it, and again, you're going to be looking for the method that has the smallest MSE, the smallest mean square error. We're also going to look at mean absolute percentage error. So first thing we have to calculate is our percentage error. And then again, sometimes that percentage may be a positive, it may be a negative. So we're going to take the absolute value of that percentage error and calculate that or use that to determine the accuracy of the forecast. So those are just some of the ways that we're going to take this forecasting error and we're going to run a few more analysis off of it to determine the accuracy of a forecast. All right, so the next thing we want to look at is the types of forecasts that we're going to be working with in this chapter, and I will start a new video for that.